Okay, so the next section in measurement is looking at area, and these are all we're looking at areas of shapes, squares, rectangles, triangles, parallelograms. I imagine these have all been looked at before, and there are probably no surprises in this lot, but it's just a little review, and then we'll get plenty of chance in class tomorrow to go over some questions and find some areas ourselves. Okay, so it's just a little recap. So firstly, we'll look at the area of our topic, our focus area is area. Okay, so let's go through the shapes that we need to be on top of, we need to understand. So for a square, well, this is, you know what a square is. It's a right-angled quadrilateral where all sides are equal. So if that side is x, then these are equal, then our area is going to be equal to x squared. Okay, no further explanation required there, I don't feel. Rectangle, so a quadrilateral with right angles, but with two pairs of equal sides. And if those sides are, it's a rectangle, right angles in those spots there. If we've got a length of x, say, and a width of y, then our area is simply x times y. As I said, this is old news for all of you, I'm sure, but having a look at it again won't harm us. So let's have a look at the triangle. So when we've got a triangle, the dimensions that we need in order to calculate the area will be the height. When we're talking about height, it's the perpendicular height from one of the vertices or corners or angles of the triangle. So let's give that h, and our base b, and so our area will be half hb, half times height times base. Get the area of any triangle for us. Okay, moving along, rhombus. This might start to get a little bit more useful now in terms of remembering what these things are. Now, rhombus is a square that's been displaced, so that we don't have right angles here anymore, but we have a quadrilateral with four equal sides, but the angles themselves are not 90. So the sides are parallel, so we've got parallel sides there, we've got parallel sides here, and all sides are equal. So I'm going to put in a little dash here so that you can recognise the symbols there that mean all those sides are equal. Now what we're interested in with a rhombus, and I've made this quite a small rhombus, and I apologise for that, but we're going to find out the area by multiplying the lengths of our diagonals together and then dividing by 2. So if that's x there, so if that diagonal is x and this diagonal here is y, you can see what I've got there, and our area is going to be a half xy. So a rhombus, all sides equal, not 90 degrees in here. We need the lengths of our diagonals in order to find the area of the rhombus, and we multiply those diagonals together and divide by 2, half xy. Okay, parallelogram. Now, a parallelogram is a rectangle that's been displaced. So similar to, it's the equivalent of a square. Displace the square, you get a rhombus, and displace the rectangle and you get a parallelogram. So the parallelogram will look like so. So it's the same sort of idea, but now so we've still got two pairs of parallel sides parallel to each other. That's important, that makes it a parallelogram. But now, in order to find the area of this shape, we take the height, perpendicular height, and we multiply it by the base. So the area is simply equal to height times base. If you think of it as a most books will have it the other way around, so I'll change that just to alphabetical order. Alphabetical order, B times H. If you think about this, it's a rectangle that's been moved along, so that's still height and that's base. So in the rectangle's case, x times y. Here, same idea. That's our width and that's our length. We can multiply the two together. So in a parallelogram's case, we just need that perpendicular height, multiply that by the base. Okay, a trapezium. Now a trapezium is a quadrilateral that has one pair of parallel sides only. So we might have this sort of situation. These sides are parallel, but the other pair of sides are certainly not parallel. What we need in this instance is to know what the lengths of our parallel sides are, call them A and B, and also what the height of our trapezium is, call that H, and the area of this trapezium will be equal to a half times the height there, times the sum of the parallel sides, A plus B. So half height brackets A plus B. Yeah, that's enough on trapezium. We're going to do kite. Now the kite is it's a rhombus without the sides being equal. So we've got a pair of adjacent sides are equal. So this side will equal this side, and this side will equal this side. So the adjacent sides are equal. There's a rough looking kite. Now for a kite, just like the rhombus, we need to know these lengths. So we need that diagonal there, which I'm going to call x, which is that length, and we need to know that diagonal there, which is going to be called y, which is all the way along, and our area of the kite, just like the rhombus, will be a half xy. Almost there. We're going to cover the circle. The circle has what do we need for the circle? We need to know what the radius is. And if we do, we're in business. The area of the circle is just pi r squared. Pi times the square of the radius. Now if we look at the sector of a circle, then just as we did in trying to find the perimeter, we need to be aware of how much of the circle we have. So if that's the circle, this is our radius right here. Then what we need to know is this angle here. I'm going to put theta, that angle in there. What does that equal to? Because if we know that, we know what fraction of the circle we've got. So we can put that angle over 360, 360 being the entire circle, and we can multiply that by pi r squared with r being there. Okay, we're all ready to go then with exercise 6C from the work requirements in class on Wednesday. See you then.